All right, good morning, my Algebra 1 family. Good to see you guys again in another video again. Hey, listen, hope you guys are watching these. You got to watch these videos. They are the lifeline between me and you at home, doing the best you can. Here, doing the best that I can to present the material just as I would normal. All right, so again, just want to let you guys know if you got any prayer requests, you got any needs, send it my way. Shoot me an email. Send me a personal message. Whatever I can do for you guys, I'm going to try to do. And the only thing I can ask is that you guys at home are doing the very best that you can to learn the material, watch the video, rewatch the video, subscribe to the channel so that you guys get the immediate access and it's not always a back and forth between Google Classroom and YouTube. Everything's just going to be directly posted there. So, yeah. All right, let's jump into section 2, chapter 11. We are simplifying rational expressions. All right, I'm going to go off to the side here. You guys pause the video, copy all this stuff down. Okay, so remember how to factor. That's going to be vital because in this chapter we are factoring again, doing more factoring. You got to remember specific things like taking out like terms. We're going to do all these example problems here that are going to show you again how to factor, take out like terms, reduce. That is vital. Reducing is very important because reducing and simplifying, they go hand in hand. All right, they are nearly the exact same concept. So we're going to show you through a lot of these examples what I'm talking about. But before we get there, there's a term here that you really need to understand. It's called excluded values. Excluded values, they are the solutions for only the denominator. So if we're talking about a fraction, that's the number on the bottom. That is the denominator. And when you're given an expression like x plus 3, and you solve that, what are you going to get? You're going to get a negative 3. All right, so when you solve for the denominator, this is what we're doing. Solve it. These answers, in other words, when you solve just the denominator, these answers would make the denominator equal to 0. And if you know that if you ever make a denominator 0 in a fraction, that is going to equal no solution. So that's why they are called excluded values, meaning if you ever got those values for an answer, it wouldn't work in the equation. All right, this is really important, especially in Algebra 2. So it's presented here in a very basic method for Algebra 1 because you will use it again later, that exact same concept. All right, so again, we're going to walk through some excluded values right here in the first 2 example problems. Now this really important note is going to come up with the last 3 example problems. So I'm just going to do a quick description and you're going to see what it looks like here. If you ever have a plus or a minus sign, like x plus 3 or 2x minus 4, that's what I'm talking about when I say a plus sign or a minus sign. If you have those, that is like a bond, all right? This is a key thing here. It's like a bond that holds that whole expression together. You cannot separate those parts. So again, if I were to say x plus 3, you can't just take away that x for no reason. The x plus 3 is a bond. It's a whole group that stays together, and that's going to come into play when we especially take a look at example 4 and example 5. This part right here, if all you are doing is multiplication or division, then you can cross out individual terms. That relates to example 3. So above this right here, I'm going to put a 4 and a 5 because this first sentence relates to example 4 and 5, and over here I'm going to put a little 3 because this second sentence relates just to example 3. All right, so let's go in these examples. Let's do these together. By the way, again, always follow along in the book during the videos. That's what I'm doing. These examples were pulled directly from the textbook. Okay, number 1, find the excluded value. Again, excluded value means solve the denominator. So what do you do with the numerator? You do nothing. You don't worry about it. That numerator, if all they're asking is excluded values, You don't care about the numerator. If they ask you to do more, like simplify or solve, yes, then the numerator comes into play. But that's not what I'm asking. All I'm saying is find the excluded values. So we don't care about that numerator, we just care about that denominator. So I'm going to take that denominator of 3x minus, 5 and set it equal to 0. Solve for x. Plus 5, there we go, plus 5. 3x equals 5. Divide both sides by 3. And that right there, 5/3, 5 over 3, that is your excluded value. So if that's all they ask for, is just the excluded value, solve the denominator, and that would make the denominator equal to 0, which is what would cause the whole thing to have no solution. So don't write no solution. That's not what you're asked. You're asked to get the excluded value, which is 5 over 3. So let's do it again in example 2. All right, just finding the excluded value. All right, so again, all I need is the excluded value. All I care about then is the denominator. So I'm going to do m squared minus 4 equals 0. Now, what are we going to get here? We are looking at basically a perfect square binomial, which means you could factor this. Another method, if you didn't want to factor it, is you could go ahead, all right, let's add 4 to both sides. M squared equals 4. Now you'll remember in the last chapter, how do I get rid of a square? By taking the square root. It's the opposite function. All right, so let's take the square root, and what you do to one side, you have to do to the other side. So these guys cross each other out, leaving just m. And what is the square root of 4? If you just say 2, that's not correct. It's 2 and negative 2. So that's a plus minus negative 2. So I have to show both parts, plus and minus negative, plus and minus 2. All right, so both parts there. Okay, so that deals with the first two examples, finding the excluded value. Let's go into simplifying, all right? You're going to remember example 3 deals with this sentence here where it's telling me all I'm doing is multiplying and dividing, which is true. 4x cubed. All I'm doing there is multiplying. 22x to the 6. All I'm doing there is multiplying. And if we look at the whole thing, it's division. So the whole equation is just using multiplication and division, which means I can start to simplify a lot of individual parts here. So let's treat it like this. If I have 4 over 22, can't I reduce that fraction? Yes, I can. A 2 can go into 4, and a 2 can go into 22. So what is that going to equal? 2 over 11. So 2 over 11 is a simplified fraction. Now let's look at this part. X to the 3rd over x to the 6th. Can I reduce that? Absolutely. I have 3 x's up here. X to the 3rd power means x and another x and another x. I have 6 x's down here. X to the 6th power means I have 6 of them. So what I can do is cross all 3 of these x's out, and that means that 3 of these x's have been used. So instead of 6 x's now, I only have 3 x's left over. And if you want the expanded version just for this one problem, so you can see it, it's like 3 x's on top and 6 x's on the bottom. So these guys would cross out, these guys would cross out, these guys would cross out. So notice there are no more x's on top, but there are 3 x's on the bottom. That's what I'm showing here. So let's put it all together. The 2 has no more x's with it, but that 11 in the denominator does. It has x to the power of 3 left over. So that right there is the full simplified expression. 2 over 11 with x to the third left there, right in the bottom. Okay, let's take a look at example 4, which now deals with this idea. You see how we have a plus sign? That's bonding these guys together. You see how I have a plus sign down here? That's bonding them together. So I can't just cross anything out quite yet. But what I can do is I can start to take out like terms. What do we have up top here? The 2 and the 8 both share a 2. The x squared and the x both share an x. So take out 2x. So we take out a 2x, and let's rewrite what we have left over. The 2's gone, and one of those x's is gone, so there's one x left over. Plus, that 8 divided by 2 gives me a 4, and that x is gone. I took it out. It's right here. All right, let's take a look at the 3x plus 12. What do they share? They share a 3. So take a 3 out, and what is left over? X plus 4. And wouldn't you know it, isn't it kind of like a magic trick? X plus 4 is on top, x plus 4 is on the bottom. Now this is what brings the whole concept together about why a plus or a minus is a bond. It holds the whole expression together. But because these expressions are identical, x plus 4 over another x plus 4, I can cross out both of them because they're identical. I'm not just crossing out the x's or just the 4's, it's the whole expression, x plus 4, all crossed out together. What does that leave me with? 2x over 3. That is now your simplified solution. The expression simplifies down to just 2x over 3. All right. Now, last example problem here, number 5. You'll notice we got a trinomial. We have another trinomial. When I look at the numerator, there's no like terms to take out. When I look at the denominator, same thing. No like terms to take out, so what must I do? Factor it. All right. So, let's see what this is going to factor to. Remember, parentheses, okay, over another set of parentheses, x squared, x with x. They're both plus signs, so in here are both plus signs. And 2 is just going to make 2 and 1. Why do we know this works? Because 2 times 1 is 2. 2 plus 1 is 3. All right, let's factor this trinomial right here. X squared, x and x. Again, both plus signs. So these guys are both plus signs. What are the factors of 10 that could make 7? 5 and 2. So let's plug that in. All right, I'm going to put the 5 over here and the 2 here. Why did I do that? I just wanted you to see, again, x plus 2, and now here, x plus 2. You see how they're isolated within the parentheses, but these are identical expressions. So that x plus 2 could cross out with that x plus 2, leaving me this part right here, x plus 1 divided by x plus 5. That would be your solution. We simplified the whole expression, first by factoring, then second by looking for the new expressions that are identical. Remember, they're being held together with a plus or minus sign, so the whole expression has to be either taken away or none of it can be taken away. So that's why x plus 2 over x plus 2 works. They're identical. I can cross them out. What's left over? X plus 1 over x plus 5. All right, guys, there you go. Another good video for you. Watch it, rewatch it. Make sure that all your friends are watching it because this is the helpful stuff that should make this concept make sense to you. All right, see you in the next video.